Let me ask you a question. When you stare straight into a mirror, what do you see? If you said you see your face or you see yourself, then you are correct. When you stare straight into a mirror, the only thing that you can see is whatever is looking at it, which is yourself. What's the name I'm looking for? What's the word I'm looking for that describes this? If you said reflection, you are right. And today's lesson is called the reflexive property of equality. Math is all about balance, and when you're working with equations, the number on the left-hand side of the equation must be equal to the value on the right. Okay, and if you just have one number on the left and one number on the right, they have to be equal to each other. In other words, 3 must be equal to 3, right? 3 cannot be equal to 4 or any other number. It can only be equal to itself. Once again, that is called the reflexive property. Why? Because what's on the left the value on the left must reflect the value on the right. Okay, for our first official example, we're going to read this together. 10 is equal to what number? And the number that we're looking for, we're going to stick inside of that box, okay? So 10 is equal to what number? I'll give you a second to think about that. Okay, being this is a very basic lesson, it shouldn't be too difficult for most of you. The reality is 10 can only be equal to itself. It cannot be equal to 11, 12, 13. In fact, it's not even equal to 10.00001. It can only be equal to itself. So this only has one step, and that is to stick the number on one side into the box on the other side. That's the simple step, right? Again, this is called the reflexive property. The number on the left must be equal to the number on the right and vice versa. For example 2, we're going to put the unknown number on the left, so let's read this together. What number is equal to 3? Okay. Let's go ahead and just rewrite the problem down below. That's a great practice if you're doing maths, to go ahead and rewrite the problem. So what number is equal to 3? Again, a number can only be equal to itself. It's called the reflexive property. So what's on the left must reflect what's on the right. And therefore, we're going to stick 3 inside the box. Let's go ahead and read example 3 together. Negative 6 is equal to what number? Negative 6 is equal to what number? And I did this example just because, guess what? There are just as many negative numbers as there are positive numbers. Okay, we're going to look at some other type of numbers here in just a second. Negative 6 is equal to what number? Again, it can only be equal to itself. It can only reflect itself on both sides, and therefore can only be equal to negative 6. Now, I do realize that some of you might be thinking, well, why can't I put negative 5 minus 1 in the box? Well, you could, but math is all about simplification. And for this particular lesson, your answer should always be one simple number. Okay, and so negative 6 is easier and more simple than writing negative 5 minus 1, and that's why we're going to just put a single number in there. Let's read this problem together. Example 4. What number is equal to 4/3? What number is equal to 4 over 3, which is a fraction? Again, this is a simple lesson. A number can only be equal to itself. And let me go ahead and tell you guys, I know some of you are thinking, hey, what's the decimal? Isn't it 1.3 repeating? Some of you might already know that. If you don't, that's okay for now. But anyways, if a question gives you the format in fraction, you can assume, unless the teacher tells you otherwise, that your answer should be a fraction. And also, if the question gives you in form of a decimal, unless it specifies otherwise, you can go ahead and put your answer in decimal form. No need to convert unless the question tells you to. So therefore, what number is equal to 4/3? Simple. Itself. And we can write a fraction that way with a diagonal slash, whatever you want to do. But yeah, it's that simple. This lesson again is called the reflexive property. The number on the left must be equal to the number on the right. They must reflect each other. Let's go ahead and look at a decimal. Negative 100.8 is equal to what number? And now all of you should have the hang of this. Whatever's on the left must be on the right, and therefore negative 100.8 can only be equal to negative 100.8. For example 6, we have what number is equal to, and do any of you know how to read this symbol? Okay, what is this symbol right here? I'm going to go ahead and rewrite it. The symbol is pi, right? We know that we can kind of come over here and approximate it as 3.14, but we also know that that decimal goes on forever, and therefore we just use pi to represent that never-ending decimal. Anyways, it's a number just like any other number, and so what number is equal to pi? And again, this lesson is all about reflection, and therefore we're not going to put 3.14 in there, guys, because that's only an approximation. It goes on forever. So don't make it harder than it is. It's just simply asking what number is equal to pi, and pi can only be equal to itself, right? So we can just put pi in the box. Okay, and again, pi represents a decimal that goes on and on and on and on. Okay, and it's just a simple short symbol that represents that. Again, this lesson is called the reflexive property of equality. It means that the quantity or number on the left must be equal to the quantity or number on the right. For example 7, we have A is equal to what number? Now I know some students get a little confused when they start to see letters in math. Let me try to help you with why we use letters. Let's pretend that A stands for the number of apples that you have in your kitchen. Okay? Instead of writing apples every time, it's a lot easier if we just write A, right? Okay? Something else it could mean is just simply a number. Okay, and I'll shorten that just so we can move on. Or it could also represent any number. Okay, instead of just writing these things out, it's a lot shorter if we just write A. So A could represent any number in the whole wide world. And so this question is asking, any number that you choose is equal to what? Okay, and again, this is a little bit more abstract, but it's not that hard. Again, we said that any number that you pick, whatever that number is, say it's 9, 7, or whatever, has got to be the same number on the right. And therefore, the answer to this one is simply A. Whatever number you pick on the left must be exactly the same number on the right, and vice versa. Okay, and again, we could actually use any letter to represent a number. We could actually use B, sometimes you'll see that, or C. A lot of times you'll see X or Y. So if you see any of those letters, they just ultimately represent numbers, and whatever that is on one side must be the same on the other side.